Hello, I'm covering section 8.1 today. I'm starting chapter 8. So if you read the description of the chapter is about consumer mathematics or the mathematics behind money management. And it says in the introduction, this may be the most important chapter you will read in any course during your entire college career. So I wouldn't say that, but it's definitely important because this chapter is about managing money. And okay, so we're going to start the first section, 8.1, about percent, taxes, and inflation. And we have been working with percents since the beginning of the semester, but let's suppose we haven't done that, and we're going to do a review of percents. So percent per means impulse division, and cent is 100. So percent means divided by 100. So this is nothing we haven't done before. Something like 15.6%. That's 15.6 divided by 100. And as a decimal, 15.6 is 0.156. So P percent means P divided by 100. And 1% represents the total of something, or 1 unit. And 1.75%, 1.75 as a percent, that's going to be 175%. 1.75 as a percent is the number. So if the number doesn't have the percent symbol, it is understood that the number is in standard form. If the number has the percent symbol, it will be understood that you are working with percents. So it's going to be that number divided by 100% or 175%. Okay, so we have several exercises. Suppose that you want to convert a percent to fraction. So in order to convert a percent to fraction, what you will do is divide the number by 100 and simplify the fraction if necessary. So 24%. If you want to convert 24% to fraction, 24% is 24 divided by 100. From the divisibility rules, we know that both 24 and 100 are divisible by 4. So 24% as a fraction is 6 over 25. If you want to convert a percent to decimal, you are going to divide the number as a percent by 100. So all you do is move the decimal point 2 places to the left. Okay, so 42% is 42 divided by 100. But 42% divided by 100, just move the decimal point 2 places to the left, and this is 0.42. If you want to convert the decimal to percent, you are going to reverse the process before, the process above. So in order to convert the decimal to percent, we're going to multiply the number by 100, or simply move the decimal point 2 places to the right and insert the percent symbol. Multiply the number by 100 and insert the percent symbol. And 0.561 as a percent is going to be 0. This is going to be 0.561 times 100%, or 56.1%. And finally, you want to convert a fraction to decimal. You will to convert a fraction to percent. We did fraction to decimal. In order to convert a fraction to percent, you are going to convert the fraction to decimal, and then convert the decimal to percent. Okay, so let's look at example 2, and example 2 is an exercise of that. Okay, so 3/8 as a percent. First, convert the fraction to decimal. So 3/8 to 3/8 as a decimal is 0.375. And as a percent, move the decimal point 2 places to the right and insert the percent symbol. And that's it. Okay, so now we can discuss percent of change. This is nothing we haven't done before. We have been working with percents since the beginning of this course. So, situation. Let's say that the value of a car dropped from $7,400 to $6,800 over the last year. So the dollar value change is 600, or a decrease of $600. The dollar value change is, so it decreased. That was 6,800 minus 7,400, and that is minus 600. the value of the car dropped. So the value decreased by 600. So it's negative. And that decrease. And this decrease was 600, or I'm going to keep it positive because I'm already saying decrease. So that's 600. So that's $600. The original value was $7,400. That's approximately 0.081. As a percent, that's 8.1%. So this decrease was 8.1% of the starting value of 7,400. So the percent of change formula, that's on page 389. And I can read that. So the percent of change is always in relationship to a previous or base amount. We then compare a new amount with the base as follows. The percent of change is going to be the new amount minus the base amount divided by the base amount. So if the new amount is less than the base amount, then the percent of change will be negative, like the situation that I just showed you. So that situation was about the decrease in the value of a car over a year. So the percent of change is negative. And I didn't write minus because I'm already saying that this is a decrease. So the increase would be a negative increase, or will be a negative increase, or the percent of change would be negative. So that's the formula. This is the formula for the percent of change. So this is the percent of change formula. And in the last example, the percent of change was negative. Yeah. Because the value of the car decreased. So I'm going over number 35. So this is about the price of a new home. Okay, according to the Federal Reserve, from 2000 to 2016, the average price of a new home in the United States increased by 83% to 297,000. To the nearest thousand, what was the average price of a new home in 2000? Okay, so back to this formula, we know that the percent of change when you do the arithmetic, you must convert the percent to decimal. And you know the new amount. So we know the percent of change, we know the new amount. We're going to write this in thousands. And we need to find the base amount. So let X be the base amount. So we're going to plug this into the formula. The new amount minus the base amount is the percent over the base amount is the percent of change. So the new amount minus the base amount over the base amount is going to be the percent of change as a decimal. So that's an equation that we're going to solve for x. We can start by multiplying x. By multiplying x on both sides or simply passing the x to the other side. Then add x to both sides. And 297. So 0.3x, 0.83x plus x. If you took a course on basic algebra, x is the same as 1 times x. And the distributive property says that 0.83 plus 1 is 1.83. Okay, so 297 is 1.83x. And we can divide both sides by 1.83. So 297 over 1.83 is equal to x. Or x to the nearest 1,000 is approximately 162. So that answers the question. That answers the question. In 2000, the average price of a new home was $162,000, approximately. We're rounding to the nearest 1,000, to 1,000. So a variation of the percent of change formula is the markup. So it works the exact same way as the percent of change. So merchants often use percents to describe the deals that they are giving to the public when they have a sale. The increase that a merchant adds to this price is called markup. So if you see, if you go to a department store, you're going to see the suggested retail price. That's going to be the base price plus the markup. And the markup that's still the percent of change formula. A markup is a percent increase. So that's going to be the selling price minus the base price over the base price. So let's see an example. So that's 395. So a computer retailer buys a multimedia computer for $1,850 and then sells it for $2,081. What is her markup on the computer? And then we're going to do part B. But we know the selling price. The selling price is $2,081 and the base price is 1,850. The markup is the percent of change in the base price so that's selling price minus base price over base price. And at the end, we need to convert that to percent. 2,081 minus 1,850 is 231. As a decimal, this is approximately 1/8. And as a percent, the markup is 12.5%. In doing this problem, Raju got an incorrect answer of 11.1%. One mistake did she make? And her mistake was dividing by the selling price. So that was A. In B, she incorrectly divided by the selling price. So if you divide the change in dollar amount by the selling price, that's actually going to be well, the result is going to be incorrect. So be careful with these mistakes. That's 11.1%. Okay. So we have done basics of percents. We have done the percent of change. And at the end, we're working with percents. We are working with the percent equation. We will conclude this section with several examples of percent problems. However, it's important for you to recognize that these problems are all variations of the same equation. In each case, we will be taking some percent of a base quantity and setting it equal to an amount. We can write this equation as percent times base equals the amount. So that's going to be the percent equation. So the percent times the base amount or times the base is the amount, the current amount. So examples of this equation. Okay, so we're going to be using the percent equation. What is 45% of 2060? We know the base and we know the percent. The base is 260. Well, and 45% is clearly the percent. Every time we do the arithmetic, we need to convert the percent to decimal. And we're going to find the amount. The amount is 260 times 0.45. So that is 117. 72 is 48% of what number? So now we know the amount and the percent. We need to find the base. According to a percent equation, 48% of the base is 72. So I'm converting the 48% to decimal. The amount is 72. We need to find the base. So it's 0.48 times base 72. Base is 72 divided by 0.48. So a calculator check gives you the base. The base is 150. And part C? $126 is what percent of 840? We know, okay, the base is 840 and the amount is 126. So we're trying to find what percent of 840 is 126. So the percent is 126 over 840. As a decimal, this is 0.15. And as a percent is 15%. Okay, let's do a couple of word problems with the percent equation. That's example 7 on page 391. At one time, the 1995-1996 Chicago Bulls had the best record in the history of the NBA, with 72 wins and 10 losses. What percent of their games did they win? Okay, so they don't tell us. They are not telling us the base, but you can find it. The amount is, they are asking you what percent of their games did they win. So we want to find the percent. The amount is 72, and the base is not given explicitly, but if they won 72 games and lost 10, the base is going to be 82. And the percent, we're trying to find what percent of 82 is 72. $72 over 82, that's approximately 87.8%. Okay. Okay, so that's about 87.8%. There's another application of the percent equation. Same page. Example 8. From 2003 to 2016, the total amount of student debt has increased 429% to 1.27 trillion, or 1,270 billion. What was the amount of student debt in 2013? We know a few things. We know the new amount. We're going to keep everything in billions, 1,270. We know the percent. We know the percent and we want to find the base amount. So the base amount is the amount in 2003. Okay, so let's put everything together into the percent equation. We're going to let X, let's see, sorry, the base amount is the amount in 2013, call it X. So the new amount minus the base amount over the base amount, and that one, there's no percent there, is 4.29. So let's solve this equation, multiply X on both sides. Then add X to both sides. And 1,270 is equal to 4.29X plus X. Distributive property, this is 4.29 plus 1 times X, or 5.29X. And X is 1,270 over 5.29. That's about 240 billion. So that was the amount of debt in 2003. And in those 13 years, it increased from 2,040 billion to 1,270 billion, or 1.27 trillion. Okay, so the title of this section is Percent, Taxes and Inflation. So taxes had a lot to do with percents. So calculating various kinds of taxes relies heavily on using percents properly. So this is an example with taxes. So I'll copy the first part of example 9 on the next page, 382. And I'm going to copy this table. Well, I need that. And finally, I'll copy the questions. Okay, This page 392. Okay, so the table below is taken from the instruction for filling out form 1040 to compute the federal income tax for a person whose marriage status is single. So they give you this table. If the taxable income is over 0, but not over 97,000, the tax is 10% of the amount over 0. If the taxable income is over 9,700, but not over 39,475, the tax is going to be 970, that is 10% of the limit on the first line, plus 12% of the amount over that, and so on. So if Jay is unmarried and has a taxable income of 53,720, what is the amount of federal tax that she owes? So they already highlighted line 3 because 53,720 is over 39,475, but not over 84,200. It's going to be that. So it's going to be 22% of that plus 4,543. So that's going to be so 53. So 53,720 minus 39,475. This is 14,245. So that is the amount over 39,475. And the amount she owes, so her tax is 4,543 plus 12% or plus 22% of the amount over 39,475, which is 14,245. Okay, so let's calculate this. This is 4,543 plus 22% of the amount, or 22% of 14,245. And that ended up being 7,676 with $90. And they are asking you, how did the IRS arrive at the $45, $43 amount in column 3 of line 3? Where is this coming from to begin with? So that has to do with the upper limit. If you look at the second line, 10% of the limit, 9,700, is 970. So we're going to do that. So the amount, so the upper limit is 39,475. We're going to do that first. So let's see. So that is the amount. So that minus 970. So 39,475 minus, I'm missing 10, minus 9,700. We're calculating the difference between these two limit values. And this is 29,775. And this is where the amount is coming from, is 970 plus 12% of that. So if you calculate this, so the amount over 9, okay, so on the first column, the upper limit is 970 plus 12% of 29,775. And yes, the amount is 4543. And the last topic is inflation. So inflation, you may hear that term quite often nowadays. I mentioned the CPI when I did the section of about real numbers. So inflation is a rise in the level of prices of goods and services over a period of time. One common measure of inflation is the consumer price index, or the CPI, which is maintained by the Bureau of Labor Statistics. The base CPI of 100, which corresponds to average prices during the years 1982 to 1984. So that's the base price. So if you were to look up the CPI for dairy products in 2016, you would find it to be 218.13, which means that on average, dairy products in 2016 cost 218.13% of what they cost in 1982-84. So the inflation rate I'm going to do this. So the inflation rate is also a percent of change. This is the new consumer price index minus the base consumer price index over the base consumer price index. Okay, so we are going to do the last 4 examples. We're going to complete a table. Recall that the consumer price index is a measure of inflation reached by comparing current prices with base prices in 1982 through 1984. However, it is a mistake to interpret a change in the CPI as the actual percent of inflation. For example, from 2013 to 2014, the CPI for candy and chewing gum rose from 138.5 to 141.2. However, the rate of inflation is not the actual percent, is the percent of change. The rate of inflation for this item was only, the percent of change was 1.9%. So for the exercises in the table, we're going to use the inflation rate formula, which is the percent of change formula, to fill the missing items in the table. Okay, so these numbers, 70, 71, 72, 73, and 74, those are the problem numbers. Those are not the actual values. So let's do number 71. the percent of increase is going to be the percent of change. So that's going to be the CPI, the consumer price index in 2015, minus the consumer price index in 2005, over the consumer price index in 2005. That's the base CPI, so this is 42.7 over 179.1. So that's, as a decimal, that's 0.238. And the inflation rate, or the percent of increase, is 23.8%. So the percent of increase in ice cream prices was 23.5%. In number 72, we know the percent of increase and the base CPI. We need to find the new CPI. So we need to find the new CPI. We are going to call this X. And the new CPI, that's X. Actually, that's not X. That's yeah, we need to find the new CPI. So that's X minus 32.235 over 3.235 is equal to 38.7. We need to write this. We need to always write the percent as a decimal when we do arithmetic. Okay, we solve this equation, so multiply the denominator. Okay, so X, so 0. What is that? So that's a minus. This is 3.235 plus 0.387 plus 3.235 is 1.252. And at the end, the CPI in 2015 is 4.487. So this is the CPI, the consumer price index in 2015. Number 73, you need to find the base CPI for milk in 2005. They give you the CPI for milk in 2015 and the percent of increase. So in number 73, find the base CPI. We're going to call this X. That denotes the consumer price index in 2005. Okay, so the percent of change formula, this is the new CPI. That's 3.310. Minus the base CPI over the base CPI. And 2.1%, we need to write the percent as a decimal, that's 0.021. Okay, so solve this equation, multiply X. So multiply or add X to both sides. And 3.310 is equal to 0.021 plus 1 is going to be 1.021 times X. and x is 3.310 over 1.021. So the base CPI is about 3.242. So this is the consumer price index in 2005. And the last one is very similar to the first one. It's very similar to 71. You know the base CPI and the new CPI. It's only that the percent of increase is going to be negative. It's going to be negative because the CPI for gas actually decreased in those 10 years. Well, from between 2015 to between 2005 and 2015, the gas prices decreased. Okay, so the percent of increase is the new CPI, the new consumer price index, minus the old consumer price index over the old consumer price index. So the percent of increase is going to be negative. That means there's a decrease. This is approximately negative 0.058. And the percent of decrease is 5.8%. Okay, so this is it. This covers section 8.1. Thank you for listening.